I would like to talk about a spontaneous process. A spontaneous process, funnily enough, is one that happens spontaneously. Let's have a look at this sandwich. If I was to leave it on a kitchen table and walk away for a few days, it would spoil, and that would happen on its own accord. So we can say that a spontaneous process is one that occurs on its own accord without outside intervention. So this sandwich will go from a good sandwich that I can eat to a bad sandwich that I cannot eat completely on its own. We also know that the reverse is not true. This sandwich will not spontaneously go from a bad sandwich to a good sandwich, which means we can also say that a process that is spontaneous in one direction will be non-spontaneous in the opposite direction. So at this stage you might ask yourself, why is it that certain things happen? Or why is it that certain processes and certain reactions are spontaneous and happen on their own, and others are non-spontaneous and do not happen? Well, let's look at that by way of analogy. So I'm going to draw an incline over here, something like that, and I'm going to place a boulder or a ball somewhere here. What will happen to it? Well, it will roll downhill all the way here. So in physics terms, we could say that we have gone from a situation where the potential energy is high to a situation where the potential energy is low or lower. So up here, this ball had some sort of higher potential energy, and that potential energy was converted into kinetic energy as it rolled downhill, and some of the energy was also converted to heat due to friction. So a similar thing happens with our reactions. So let's say we have a reaction between an acid and a base, and we will get water and salt. So this is a reaction that you have probably done in your chemistry lab. You mix some acid and a base, and on their own, they will spontaneously react to give you water and salt. And you may have also noticed that they will release some heat. So in terms of energy, we could say that our reactants are somewhere up here, and our products are somewhere down here. And the change in energy, or the change in enthalpy for the system, for this reaction, is this difference between the reactants and the products. And in this particular case, the difference between the products and the reactants, I should say, was negative. The enthalpy, or delta H, is negative. And so this reaction is exothermic. So you might say, well, maybe that's the key. Maybe a spontaneous process is an exothermic process, a process where heat is released. And you would be partially correct. It is true that many exothermic processes are indeed spontaneous. Some of them are not. However, there are also some endothermic processes, so processes that require heat or energy, that are spontaneous as well. And you know one. Let's say I place an ice cube on that very same kitchen table next to my sandwich. If I was to walk away, after a while, I would find a puddle. So this is an endothermic process. This ice cube requires heat. The system, our ice cube, needs heat in order to go from a solid state to a liquid state. So it is an endothermic process, a process that requires the system to gain energy, and yet it is still spontaneous. However, at this stage you might say, hold on, yes, that is true, however, it is temperature dependent, and you know that. So for this ice cube to melt, the temperature needs to be greater than 0 degrees Celsius. So where does that leave us? Well, we can say that our process will be spontaneous, or more precisely, whether a process will be spontaneous or not, will depend on enthalpy, sure, as is the case in our exothermic reaction of acid and base, but it will also depend on temperature, as is the case in our endothermic reaction, or more precisely our endothermic process of the ice cube being converted from solid to water, to a liquid state. And that is not, unfortunately, that is not the end of the story. So yes, enthalpy plays a role, temperature plays a role, but there is one more component, and that component is entropy. And entropy is somewhat of a tricky thing and somewhat hard to define at times, so I will leave it for future videos.